Hello everyone. So now next thing which we are going to start is your dot product. Okay, multiplication of the vectors. Okay, in which we are going to first define is dot product. We also call it scalar product. Okay, and let's write down about it. We are going to discuss in this video about this thing. So first, how we define the dot product. So dot product is basically if you are doing dot product of a vector and b vector. Okay, then that is all. We can write it a magnitude of a into magnitude of b into cos of angle between them. Simple. Okay, so this is coming in a scalar quantity, that's why it is known as scalar product. Okay, doing the scalar multiplication. Okay, so a vector dot b vector equals to magnitude of a into magnitude of b into cos of angle between them. Okay, I can write here a equal to magnitude of a vector. Okay, and b equal to magnitude of b vector, and theta equal to angle between a vector and b vector. Simple. Okay, I hope this is clear. Now next thing, so if I have, let's do some standard dot products. Okay, standard things we can write down. So I cap dot I cap. Okay, so what will be I cap dot I cap? Okay, just think once, pause the video. So what can say I cap means magnitude 1 into 1 into cos of angle between them. So I angle is 0, so that is 1, right? So I dot I will be 1. Okay, similarly j dot j, that will be 1, and k dot k is also 1. Okay, if I write down I cap dot j cap, that will be how much? Cos 90 is 0, right? Similarly I dot k will be also 0. Similarly j dot k also will be 0, right? I can write this thing. I hope this is clear. Okay, next thing which we have is your note. Okay, now see what is note is saying that a dot b is equals to b dot a. So you write ab cos theta or ba cos theta, same thing. Okay, so this is commutative property it possesses. Okay, next thing is your a dot b plus c vector is equals to a dot b vector plus a vector dot c vector, means you can distribute, so you can just multiply inside, that's all, nothing. So it is distributive property also it follows. Okay, next thing which we have dot product in component form. So how to write in component form, that is written. So let's say we have, let a vector we have ax I cap plus ay j cap plus az k cap. Okay, and we have b vector that is equals to bx I cap plus by j cap plus bz k cap, that we have. Okay, so then find out a vector dot b vector, a vector dot b vector. Okay, just put these values, ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. Okay, so expand this. If you do dot product, what you will get? A vector dot b vector. If you see here, you will do I dot I, that is gonna 1. Okay, so ax bx. Okay, ax bx. When you do I dot j, that gonna be 0. So I dot k, that gonna be 0. Then j dot I, that gonna be 0. J dot j, that gonna be 1, right? So plus ay by. Similarly here az bz will come only. Other quantities got 0. Okay, other quantities got 0. Okay, so this is your a vector dot b vector. I hope this is clear. This is how you solve. Okay, x component into x component plus y component into y component plus z component into z component is the dot product if it is given in terms of I cap, j cap and k cap component form. Okay, so now you know a vector dot b vector is ab cos theta. So when it will be maximum? When the cos theta is maximum. So theta is 0 degree, then it will be maximum. And when cos theta is minimum, means -1, then it will be minimum minus ab. Okay, cos 180. dot product of two vectors of perpendicular to each other is 0. This is very important property. Okay, dot product of two vectors which are perpendicular to each other is 0. So if someone says me that two vectors are perpendicular, so I can put dot product equal to 0 and I can find out whatever value I want to. If I want to check that these two vectors are perpendicular or not, what I will do, I will do their dot product equal to 0. Okay, next thing, dot product is always termed as scalar product because output of dot product is scalar quantity. I already told this. Okay, I hope this is clear. Now next thing is, if a vector equal to 4 and b vector equal to 3, a is directed 30 degree north of west and b vector is directed 30 degree east of south, then a vector dot b vector will be equal to. Okay, now you have to define first direction. Okay, you try to solve it by yourself, east, west and north and south. Okay, by axis, if you define x and y axis, by x and y axis, if you define, what is saying about a is directed 30 degree north, 30 degree north, 30 degree north of west. So from west 30 degree north, 30 degree towards north, a vector is lying with a magnitude of 4. A vector with a magnitude of 4, it is lying 30 degree like this. Then he's saying b vector is directed 30 degree east of south, 30 degree east of south. Okay, so from south you go 30 degree towards east, 30 degree east, 30 degree. Okay, that is b vector. Obviously if this is 30, this is 30, they are not at 180 degree angle to each other. Okay, just it is looking like that, it's not. Okay, they have a 30 degree deviation, 180 minus 30 degree. So if you want to find out a vector dot b vector, what it will be, a b cos theta. This thing which we done drawing the vectors, this we did for the calculation purpose of the angle. Okay, so a we have 4, b we have 3, and cos of, what is the angle between this, 90 plus 30 plus 30, right? So 90 plus 150, right? Okay, so 150. So okay, so 4 3 are 12, 12 into this will be minus root 3 by 2. Okay, that will be minus 6 root 3, your a vector dot b vector. That's how you calculate. Next question we have, if a vector equal to this and b vector equal to this, if a and b are perpendicular to each other, then find value of a. So we have already seen in the second note. Okay, I have told you this is very important. So what is the note? A vector, if both are perpendicular, a vector dot b vector equal to 0, right? And component form it is given I cap, j cap, k cap. So I know how to do dot product. 2 into minus 3 plus 3 into 4 plus 4 into minus a equals to 0. This will come. Okay, so from here if you calculate a, it's gonna be 6, 12, 12 minus 6 divided by 4. Okay, so this is gonna be 3 by 2. I hope this is clear. Okay, so 4th is a 12, 12 minus 6, 6 and 6 by 4. Okay, 3 by 2 answer. Okay, I hope this is clear. Now next thing is use of dot product. Okay, how to use the dot product. Okay, how we can use the dot product in various calculations. Okay, so finding angle between two vectors. Now if randomly two vectors are given and you have to find out angle between them. Okay, so that time you can use the dot product. How? You know this formula, right? So from here cos theta I can say a vector dot b vector divided by mod a mod b. Okay, dot product divided by magnitude of both the vectors. Okay, that's how cos theta came. Okay, very important formula, very important formula. Okay, like this. Okay, now till now you don't know how to calculate this, right? If you leave the dot product, you don't know how to calculate these angles, right? So we will use the dot product only. So cos theta equal to a vector dot b vector divided by ab, right? So that is A dot B, if you find out, 1 into minus 1, right, plus minus 1 into 1 plus 1 into 1 divided by magnitude, that is root 3 and root 3, root 3 and root 3. Okay, so minus 1, this is 1, so this is going to be minus 1 by 3 cos theta. Okay, I hope this is clear. So from here theta I can see cos inverse minus 1 by 3. Okay, now next note we have. Okay, what is the note here? That if, let's say, we have a vector, that is ax I cap plus ay j cap, okay, and angle with, so this is a vector is given, and this is your alpha, this is your beta, okay, right, so this is your ax and this is your ay, okay, so this is given an angle with x-axis. Angle with x-axis I can say tan alpha, right? We already know tan alpha is ay by ax, right? We already defined these things, I don't have to tell again. And angle with y-axis I can write tan beta. Tan beta is what? Ax by ay, right? And with z-axis coming out of the plane, right? Out of the plane. So with z-axis, what is the angle he is making? Angle with z-axis, what we can say? 90 degree, right? Okay. So tan alpha. Okay. This is alpha. This is beta. Okay. Angle with z-axis is 90 degree, right? That's what we can say. Now if you define in 3D, if you have a vector like this dotted line is your z-axis, okay, so let me write down. With x-axis it is making angle alpha, okay, with y-axis it is making angle beta, and with z-axis it is making angle gamma, okay, like this. Then how to find out this alpha, beta and gamma, that we are gonna write. Okay, this is your a vector basically. Okay, so a vector is given ax I cap plus ay j cap plus az k cap, whatever, right? Okay, now if you want to find out the alpha, beta and gamma, then how you will find out? Okay, I can write magnitude of a, that is under root of ax square plus ay square plus az square, right? Okay, now I defined alpha, beta, gamma, whatever it is. Okay, now how to write down angle with x-axis? Let's find out angle with x-axis. So what I am trying to find out is angle between a vector and x-axis, right? So x-axis we can take one vector. What is vector we can take? I cap, right? I cap I can take towards the angle. So you find out the angle between a vector and I cap, that is only the alpha, right? Okay, so that I can write how? A vector dot I cap is equals to magnitude of a into magnitude of I cap, that is 1 into cos of alpha, right? So from here cos alpha, what is the a vector dot I cap? Ax, right? This is ax by a, right? Similarly, if I want to find out for y-axis, then cos of beta, that gonna come same thing, ay divided by a, and cos gamma is gonna come az by a, same thing, right? This thing we can write. Okay, and this is very important. You can write same thing for ax. Okay, here just replace with j cap, that's all. Okay, I hope this is clear. Okay, now you have something important, two properties you can write for this alpha, beta and gamma. Okay, you can, how you will do this? Okay, just square and add all the things. Okay, you will get the first property. Okay, first one, and then you, all the cos square alpha you write 1 minus sin square alpha, 1 minus sin square beta, 1 minus sin square gamma, then you will get the second one. Okay, this you can also remember. Okay, this alpha beta gamma relation between alpha beta and gamma. Okay, now is asking same, this formula based question, one question we have, that is find angle made by a vector with x, y and z axis. So I can write cos alpha is equals to 1 by magnitude of this, magnitude is 1 by root 4, that is 2. Okay, so alpha is equals to 1 by 2, that is 60 degree. Okay, alpha equal to 60 degree. Then cos beta, I can say this is also 1 by 2, that is beta is also 60 degree. Okay, and cos gamma is equals to root 2 by 2, that is 1 by root 2, so that is gamma is equals to your 45 degree. Okay, I hope this is clear. So this is how you can find out angle also. Now next very important thing is finding projection of the vector along another vector. Okay, finding projection, how to find out the projection. What is projection first of all? So if you have any vector like this, okay, we have a vector here, one side only, not the other side. Okay, this is how. So we have two vectors here. This is your b vector and this is your a vector, and you want to find out a vector projection on b vector. Means projection, basically you are falling a light like vertical like this. Okay, then it will make a shadow, that is only the projection. Okay, so do you do a perpendicular, this is your projection. Okay, okay, what can I say? This projection will be a cos theta, right? Magnitude is a cos theta, direction is along the b. Okay, that is basically the projection meaning. Okay, so okay, I have told you this thing, how to, what is magnitude is a cos theta and direction is b vector. So what is the direction of projection of this a cos theta b cap, right? Simple. So from here what I want to find out, a cos theta. So we are reading the application of the dot product. So a vector dot b vector, how to solve with the help of dot product. A vector dot b vector equals to a b cos theta, and what I want to find out, a cos theta, right? A cos theta, that is equals to a vector dot b vector divided by magnitude of b, right? So I can write it like this also, a cos theta equals to a vector dot b cap, right? This is your magnitude, right? So I can say component of a vector along b vector. Okay, in terms of magnitude, if you talk, that is a vector dot b cap. Okay, and second thing is, if you ask in terms of vector form, so projection of a vector along b vector in terms of vector form. So what can I say? Magnitude is this a vector dot b cap, right? And direction is what? B, along b. So I can say b cap, right? And if you want to find out the perpendicular projection, I will explain this thing also. Projection of a vector in direction perpendicular to b vector. So parallel projection, magnitude is a cos theta, right? A cos theta towards it. So a cos theta we already calculated, a vector dot b cap. So direction is b cap. So add this thing, okay? Magnitude and direction, right? If now I want to find out this projection, vertical projection, okay, perpendicular projection. So what it will be, I can say from here that this horizontal along the projection plus vertical projection equals to its vector, right? Right. So what it will be, the what will be vertical projection, the vector minus this horizontal projection, right? So a vector minus horizontal projection, that is a vector dot b cap in direction of b cap. This is your perpendicular projection, okay, right? Because horizontal projection plus perpendicular projection equals to the vector. So this perpendicular projection equals to vector minus a cos theta and b cap, okay. Now let's solve for this next question. A vector is given and b vector is given. Find projection of a along b. First magnitude only, okay. So you don't have to remember these formulas. If you want, you can remember, otherwise you can directly solve. So we know a vector dot b vector is equals to ab cos theta, right? He's asking me like this is a and this is b, okay. He's asking me this magnitude a cos theta, okay. So I know from here a cos theta equal to a vector dot b vector divided by magnitude of b, okay. So a vector dot b vector is what, 2, and from here -1 and then -6, right? Dot product, and b magnitude of b, what is the magnitude of b here? Root 14. So this will be how much? -4 -5, -5 by root 14, okay. And then he is asking with direction. So with direction means a cos theta in direction of b cap, okay. So a cos theta we already calculated, -5 by root 14, okay. And b cap, what can I write? 2 I cap minus j cap plus 3 k cap divided by root 14, okay. So that is -5 by 14 and 2 I cap, you can multiply inside also, that is your choice, minus j cap plus 3 k cap, okay. This is your with direction projection, okay. Okay, next question we have, if p is this and q is this, then find component of q along p in vector form, okay. Find component of q along p, okay. So first you have to be cautious with what he is asking, which vector projection on which vector, okay. He's asking find component of q along p vector, so you have to answer this thing, a part. What you have to answer, q cos theta. So basically q vector dot p cap into p cap, direction of p cap, that he is asking, okay. So if you solve for this, how you will solve? Dot product first you calculate. So this p cap is basically p by magnitude of p, right? So q dot p divided by magnitude. So I have the multiplication in the magnitude, okay. So that is basically my 4 I cap minus 4 I cap plus 3 j cap plus 5 k cap dot 2 I cap plus j cap minus k cap by root 6 and multiply by which 1 mag 2 I cap plus j cap minus k cap by root 6, right? This vector, this is dot product, okay. So if you calculate the value, this will be how much? This will be my minus 10 by 3 I cap 6, this is gonna 6, okay, and minus 5 by 3 j cap plus 5 by 3 k cap, okay. This is gonna be my answer. Now b part, what is asking? B part, component of q perpendicular to p, okay. That means he is asking q minus this vector which we got, q minus this vector, minus 10 by 3 I cap minus 5 by 3 j cap plus 5 by 3 k cap. This he is asking. So q vector we know, you can subtract it, so you will get 2 by 3 I cap plus 14 by 3 j cap, okay. 3 3 is 9 9, okay, right. plus 10 by 3 k cap. This is what you get, perpendicular component, right? Okay. Now next small thing, very small thing. Okay, just work done formula. This, if maybe you encounter a question in the dot product only, so work done is basically force dot displacement, right? It is not asked majorly, but still we cover this thing here. We will cover in brief in the next chapters, but here it is written just this much only. Okay, so fine, initial point is this, and final, now next question is given on this also. Initial point is given 0 comma 1 comma 2, and final point is given 3 comma 2 comma 4, right? So I can find out the displacement vector, S vector. What is S vector here? Final minus initial, so 3 minus 0 I cap plus 2 minus 1 j cap plus 4 minus 2 k cap. That is what? 3 I cap plus j cap plus 2 k cap. Okay, and force is given, so now I know work done is equals to F dot S, and dot product I can do, right? So that is 3 into 2 plus 1 into minus 3 plus 2 into 1, that is equals to, if you do the dot product you will get 6 minus 3, that is 3, 3 plus 2, 5. Okay, so this is going to be work done equal to 5 joules. Okay, leave the unit, we will discuss later on. Okay, so for this video this much only. Okay, what we discussed about the dot product in its application. Okay, thank you.